At the drawing page, let the mouse hover over the Draw button. After a second or two, a message will appear to remind you that, in addition to clicking the button, you can access the Draw menu by pressing the D key on the keyboard or Alt-D. Then select the option for Flange Gear Miscellaneous. Then, from the next menu, select the option for Gear or Spline. The first time you create a gear, most of the data fields will be blank. You have 3 types of gears to choose from. I will pick Spur Gear. I will create a gear with 34 teeth. The help image disappears and the gear is displayed. At the bottom of the gear is the overall outside diameter and radius. I will change the pitch radius to 13 inches. Next, I'll set the finishing tool. The downward pointing arrow on that data field means that if you click it or press the Enter key while the cursor is on it, some type of menu will appear. You could enter the tool information in these data fields one at a time, but instead I will click the Tool data field to bring up the list of tools. You can edit this list, which is useful if you are using a certain number of tools over and over. The mouse icon shows the message, Slide right for more, and there are arrows pointing to the right. This reminds you that if you want to edit the tools, just slide the mouse over to the right edge of the window, and the specifications will appear. You can also press the right arrow key on the keyboard a couple of times to do this. Once the specifications appear, you can jump from one tool to the next with the mouse scroll wheel or the page up and page down keys, as the message along the bottom of the screen and the title of the window will remind you. If you leave a data field blank, that means when you pick the tool, it will not set that particular field. For example, the default depth for this tool is blank. So when I select this tool, it will not set the depth of cut. I will select this 1/4 inch diameter end mill. If you want to cut a hole in the center of the gear, such as for a shaft, specify its diameter. I'll specify a 3-inch hole. If you don't want a hole, enter 0 or press the Delete key, as the message along the bottom of the screen reminds you. If you forget what some of the data fields mean, click the menu button that is next to the OK button and select the option to show the help image. You can also choose to show the help file if you want more details about creating gears. If you plan to make this gear again in the future, or if you just want to save the parameters so that you can remind yourself what the parameters were set to, then click the menu button and select the option to save these settings on disk. Give the file a name and save it. In the future, if you want to open one of your data files, click the menu button and pick the option to open a settings file. This will show you the gears that you have saved. When you have finished specifying the gear, click the OK button. This will bring up a menu which gives you the option of creating spokes for the gear to reduce weight or to be decorative. I will choose the option to create spokes. There are 3 different types of spoke patterns. I will select the wedge style. If you have never created spokes before, most of the data fields will be blank. However, the outer radius will be estimated for you so that the spokes fit properly into the gear. Sometimes a data field displays a face with an open mouth. That face is intended to grab your attention and make you realize that it is a required field that you must put a value into. The data fields that are blank are often optional. One of the required fields is the number of spokes. I will specify 5. Another required field is the width of the outer spoke. I will specify 1/2 an inch. Once I specify that, the face with the mouth disappears from the inner spoke width, which means that that data field is now an option. For the inner radius, I will specify 3 inches. I have now specified enough information to create the spokes. These spokes are rather thin, so I'll change them to a width of 1.5 inches. If you want the spokes to be tapered so that they are thicker at the center, set the inner spoke width to a larger value. I will try 2 inches. That is not much of a taper, so I'll try 3 inches. If you forget what the brace width is for, click the menu button at the top of the page and select the option to show the image. The braces will stiffen the spokes or make them decorative. I'll specify a brace width of 1/2 an inch. That looks a bit too thin, so I'll try 0.8 inches. Since this is the first time I created spokes, MillWrite sets the radius for the braces to the center. I will change the radius to 8 inches. Now I will change it to 9 inches. At 9 inches, the braces are more for decorative purposes than for stiffening the spokes. I'll put it back to 7 inches and then select the same 1/4 inch diameter tool for cutting the wedges out of the gear. If you want to save the spoke parameters, click the menu button and select the option to save the settings. You also have the option of opening one of the setting files that you saved. I'll pick the Open function and then select this pattern of circles. When you open one of the setting files inside of a gear, a chain sprocket, or a notched circle, MillWrite will automatically scale it to fit. Now I will pick a pattern of slots. When you are finished specifying the spokes, click the OK button. After you have created the gears and spokes, you can adjust them if you decide you made a mistake. I will let the mouse hover over the spokes. When the information about it appears on the right side of the screen, slide the mouse over there and click in that area. Or press the E key on the keyboard for edit, and the mouse will go over there for you. At the Item tab, you can adjust the design of the spokes. For example, you could switch back to wedges. To adjust the tool information, switch to the Tool tab by either pressing the Tab key on the keyboard or by clicking the Tool tab. When you are finished setting the data fields, move the mouse back into the drawing and click the left button one time to let MillWrite know that you are finished editing the data fields. Next, I will let the mouse hover over the gear, and I'll zoom in on it a bit, and then I'll slide the mouse over to the Item tab to show you some of the changes you might want to make when you are cutting gears out of soft materials like plastic or plywood. Specifically, you might want to reduce the dedendum. The figure in parentheses is the figure that is calculated according to what a standard gear should be. However, for soft materials, you might want to reduce that value to make the teeth shorter and stronger. Reducing the addendum will reduce how far the teeth extend outward. This is useful when you are creating a spline, such as for a coupler. Press the Delete key or Enter 0 to return to the calculated value, as the message along the bottom of the screen reminds you. Next, I will set the machining batch for this gear to a larger number. The machining batch and the machining order determines the order in which the geometry is cut. In this case, I want the shaft hole to be cut first, and then the spokes, and then the gear. When you are cutting items that are independent of one another, the best thing to do is to put them into different machining batches. That keeps each of them separate from one another. I will leave the shaft hole at machining batch 10, and then to make the spokes cut next, I will give the spokes a larger machining batch number, such as 20. And then I will set the machining batch for the gears to something even larger, such as 30. It does not matter what the numbers are, but it's best to put gaps between them in case you want to insert some other machining operations between them. I will set the depth of cut to 1/2 inch and specify that the tool cut no more than 0.3 inches at a time. This tells MillWrite that it cannot cut more than 0.3 inches deep at a time. So in order to cut a gear that is 1/2 inch thick, MillWrite must make 2 passes. MillWrite will automatically make the passes the same depth. So for 2 passes, it will make them 1/4 inch deep. I will also set the shaft hole to 1/2 inch deep. I can then switch to the 3D View tab to view the tool path and get an idea of what the tool will cut by switching to the 3D model. If it looks okay, I switch to the NC program page. And there is the CNC program. It is ready to send out the serial port to the CNC machine or to be saved on a USB memory stick.